In this video, I am going to talk about a little experiment that I wanted to do. You see, the vernal equinox is coming up fast, and I thought it would be very interesting to see if I could measure what a day looks like from an intensity perspective as the sun rises in the east and sets in the west. So if you're interested, I would welcome you to grab yourself a cup of Java, sit down, and come on the adventure where we will be looking at measuring the length and behavior of a 24-hour period dated March 7, 2019 as we look skyward. Whether you're a CEO or a high school student itching to get an A in their science fair project, this video might be just for you. And with all the software being free, that's a bonus. So how did I start? Well, to begin with, we need some hardware. In this case, a computer and a webcam. I'm using an older tower with an 8 USB port setup, 4 GB of RAM, an Intel Core i5 CPU 760 running at 2.80 GHz with 4 processors. It is a 64-bit hardware platform, therefore I'm running a 64-bit Ubuntu 18.04.2 LTS operating system with 3 terabytes of disk space. The webcam I'm using is a Logitech QuickCam Orbit AF 2.0M with an effective pixel, USB driven. The software I'm using is GUVC View, standing for GTK plus UVC Viewer. It's a free software webcam application for Linux desktops and is compatible with V4L2 camera devices using Linux UVC, which stands for USB Video Class Drivers. The next product we use is GIMP. GIMP is a GNU imaging manipulation program, and the GNU stands for GNU is not Unix. This program runs on a variety of systems, Linux and other Unix-based operating systems, as well as Windows and Mac OS X. It is a very powerful program, and although somewhat intuitive under the hood, it will take years to master. With that said, there is a great community out there to help you along. The other product we'll be using is ImageMagick, which is a free open source powerful software suite displaying, converting, and editing rastering images. It can read over 200 image formats. Created in 1987 by John Christie when working at DuPont to convert 24-bit images, 16 million colors, to 8-bit images, 256 colors, so that they could display them on most of the screens. Details on how to install the Linux package will be placed in the description field, as this application is not offered in the Ubuntu repository. The other program we'll be using is Python. No, it's not a cup of Java. Oh, and no, it's not a large, heavy-bodied snake wandering through the tropics killing its prey by constriction. Although that still might be the case. It really is a high-level general-purpose programming language created and first released in 1991. It's become a language of choice from everything from network to cloud-based applications. In this case, I'll be using it for image manipulation. The other product we'll be using is R. Nothing new here. It was first developed by John Chambers back in 1976 at Bell Labs, believe it or not. This statistical programming language hasn't changed much. It used to be called S, but two developers by the name of Ross and Robert in the University of Auckland, New Zealand, revitalized it back in 1992 to 1995 with a stable beta version in 2000. Since their names are Ross and Robert, they named it R. And finally, the other program I'll be using is LibreOffice Calculator. Yeah, it's a spreadsheet, and it'll be useful. The approach. Well, I've connected my webcam into a USB port. I powered up the program GUC View, and I'm going to go to File, and as you can see, I've created a number of images already over the last 23 hours. For the purpose of this demo, I'm going to create another folder and call it Test, and I will call this Test. And I will save it. You notice that I have set increment file name because I want to generate a set of images over a period of time, and I don't want to overwrite the same image, so I'm going to increment the file name. As a result of that, you will see that it'll be test 1, test 2, test 3. Now, once I'm satisfied with this connection, I'm going to power off this program, and I will type in GUVC View, and I'm going to set the time. In this case, time is in 5 seconds increments, and for the purpose of this demonstration, I will set it to 10 seconds. I'll set it to 10 seconds. Why not? I want to point out one thing. When we set the timer, to grab an image, we get this message here. Could not grab image, select time out, resource temporary unavailable. The reason why I'm seeing that message is because the first image has not been processed yet. Remember that it's on elapsed time, so that the first picture won't happen until your time is up, and that is in the next 10 seconds. Once that's done, we see here that we get saving image to test 1. So let's run this again and allow it to happen. Well, you'll see that there is a preview window here, and the GUVC view is 5.46 frames per second. What does that mean? Well, the video side of it is required to always be running. In some cases, in complete darkness, if the GUVC view cannot determine what the frames per second is, you will get an error stating that, and as a result you will need to turn on some lights and get the camera configured. Stop the video. I could choose stop here or Control C. I'm going to choose stop and capture, and by doing so I can now quit the program and I get this. So what did we see here? We see the images are going to family webcam test, and as you can see we have this. So if I go to files, pictures, webcam test, here are my images. Not much happening. Once we've captured the images, as in the case of Sky 1 every 15 minutes, the Sky 94, I'll copy these images to a secondary area. You know, we spent 24 hours collecting them. Let's not lose them. So I'll go to a cropped area. Now what I want to do is I'm going to open up some of these images and just take a look at what it looks like. And as you can see, it's dark, gets brighter, gets brighter. There's the sun, and it sets. Nice. So what I'm going to do is I'm going to find a spot right here, I think, Sky 72. I'm going to open up GIMP and I'm going to take this section and use it. Sky 72. What kind of information can I get out of it? If I click on the properties, it happened at 2 o'clock in the afternoon. So I will open it, and that's the one I want. I'll take GIMP and I'm going to drag it into GIMP. There it is. And I am going to use the tool set right here to capture this area. This is the area I want to look at. So knowing that, I'm going to look at this here and I'm going to see the position, and I'll write this down. Position is 89 by 70 and the size is 217 by 168. This is important because I'm going to need that when I'm doing my cropping. So that's all I need to do there. That's all I'm going to do. I'm going to discard the changes. I'm going to close GIMP. I don't need it anymore. So the next step I'm going to do is so we've done the preparing of our images. I copied the images to second area. After all, it took 24 hours to collect them, so we don't want to lose them. We opened up some of the images to see where the best place to crop the image is. Using GIMP, I took one of the images, 72. I used the rectangle selection tool to get the X, Y, width, and height values of GIMP. Now I closed GIMP. Didn't have to, but I did. And now I'm going to go into the cropped area. And the best way that I find doing that is I just go here, and that's the parent folder. I'm going to select it and copy it, and I'm going to do a change directory, and I'm going to paste that in here, and there you are. I'm there. So now what I'm going to do is I'm going to use the image magic solution called MOGRIFY, Morgify, and I'm going to crop it, and I'm cropping it to the width times the height. That's the size. Width and height is the size. So 217 by 168, and I'm going to add the X and Y, or the positions. X is 89 and Y is 70, and these are JPEGs, so I'm going to use the asterisk.jpg to do all the images. So here we go. Boom. It's pretty fast. It's done it. I could see that there's some failures here. Text zeros. There's 3 of them. Don't know why that's the case, but I will just delete them because I don't need them. And let's take a peek of what they look like. Black. And as we can see, as we move down the trail, it should start to slowly get brighter. This is the area. Oh, we got an airplane in here, some clouds, the sun, more clouds, and stuff like that there. Okay, well, you know what? It's a good enough image. What we could do, what's really cool about R, and I'm going ahead of myself here, but with machine learning and artificial intelligence, we had a perfectly clear sky. When we get into situations like this, we could say, well, what kind of object was that? It might have been the sun. What was this? Oh, there's a slice through here. Might be an airplane. We could put that in there as an AI or machine learning solution. Anyways, let's go. The data looks pretty good. Let's look at processing. So we deleted some of the 0 byte values because there's no point in keeping them. And let's look at Python. So you'll see that I wrote a script here. I'm using SciPy. SciPy is a scientific API. I'm using datetime to pull some delta time zones. Importing with OS because I am now going to run this program. It'll be relatively fast. I'm looking at time, file name, red, green, blue, and a value. The value is the red plus the green plus the blue, as shown here, RBG 0, 1, and 2. That is the grayscale value of the image, and let's run it. Boom. It's running. It's done. Pretty fast. So now that's done, I'm just going to close PyCharm. I don't need it. Exit. And let's look at what it did. It created Sky CSV. Now, like I said, I'm going to open it with LibreOffice Calculator. I'm going to import it as so, and there I have it. All 92 images with this time zone and this here. I don't really need the time. This is the time it was processed. It's kind of useless. But what I can do is I can sort, and there you have it. So what I'm going to do next is I'm just going to copy these files and the file name over here, and I'm going to take this and I'm going to do a text to column. And first of all, I'm going to get rid of the hyphen, other hyphen. There you go, I split it. And then I'm going to do another text to column, and I'm going to get rid of the period as my separator to get rid of the JPEG file. And there I have it. I have this here. Now, why would I do that? Well, as you can see, unfortunately, this is considered a character-based solution, and as you know, with all spreadsheets, it seems that we see this as 1, 10, 11, 12. It goes up to 19, 2. Well, that's the wrong configuration. So I'm going to take this and I am going to create, I'm just going to plop it into time here, and for the time being, because now I could sort. I'm going to get rid of this, and I'm going to sort this against time, and there you got it. Now, what's important to realize here I'm going to insert 2 columns here. I'm going to call one actual, the actual time. I'm going to call this one time. What's important here is to recognize 1, 2, 3, 4, 5. These are intervals of 15 minutes. So the numbers represented in my case are 15 minutes or so. I have to multiply by 15. What we should then do is we should also indicate, in my case, Sky 1 original webcam properties. It was first done on March 6th, 2019 at 20 hours 15 minutes, thereabout. So what I'm going to do with the calculator here is I'm going to set a time of March 6, 2019 at 2015. Right? That is the date. So the actual is going to be this. Oh, before I do that, let's fix this up. This time is 15 times this. The actual time is going to be, well, actually, I'm going to change this because this is Sky 1. It was at 15, so I'm going to change this to 0. So that when I add 15 to it, it'll be 2015. So I'm going to add it by doing this. Now watch this. I'm going to make this into a $sign. And watch this. I'm going to add B. Oops, sorry. I'm going to add B2 divided by 1440. The 1440 is equated to the time calculation, and that will give me the value that I need right there. So what I could now do is I could take this and I'm going to drag it all the way down to 94 here, and now I have the time in minutes as well as you can see, I'm almost at 1440. It was almost 24 hours, 1440 minutes, and it's 24 hours. And this is what I have here. So what I want to do before I save this off is I'm going to take this, I'm going to copy it, and then I'm going to paste it over top of it first. Copy, paste as number format, paste special, numbers only, yes. And this one here, I am going to go copy, space, paste special, dates, date and time. Okay, yes, there we go. I also notice I got rid of my time here, so I'm going to put time here because I need it. And I'm going to delete this one because I don't need that one anymore. And I'm going to delete this. I want to make it nice and clean for the CSV file. There you go. We got the actual, which I'm going to do lowercase, time, file name red, green, blue, and the value, which is black and white. And I will save it over top using the CSV format. Done. So we've cleaned everything up, saved it as that. Now I'm going to close this. Okay. Now we've opened up our studio, our version 3.4.4, someone to lean on. I got to import some libraries. I'm going to be using these libraries. These are the libraries we're loading. Reader to read the file, ggplot2, and the other guy, mgcv, which you'll see why later. Once we've done that, I'm going to be able to open up Sky by reading first the CSV file. As you can see, I'm using character for actual. It's going to be used for referencing purposes more than anything else. I will then assign my values. A for actual, X is my time, red is R, B is blue, G is green, V is value. Done. Let's do some plots. If I plot the red, you could see that it's dark. I think it's brighter. It peaks out at 1200 and drops. So if I look at 1200 here, they're about, let's say 1170. So it peaked out at about 1500 or 3 p.m. That's when the sun crossed our path. For the purposes of, now this is just a test, and I'm going to now be able to use this information to determine, here's the gray value, here's the blue value, that's interesting, and the green and the red. So what I'm going to be able to do from these observations is I'm going to be able to determine when I want to do the vernal equinox, springtime, how I should position this camera. I'm thinking the camera should be positioned to the north and just look at the blue sky. and keep the sun out of the picture. But again, this was for a purpose of testing. Now I'm going to create a data frame and model it and see what it looks like. So the intercept value is actually not very good. It's saying no space, so it's 0.1 accurate. The V is good. Close this for a better view. So the formula I'm using is this one here. Let's plot this and see what it looks like. Residual versus fitted, not bad. Normal Q looks okay. Residuals versus leveraged, not too bad. Cook's distance doesn't play a role. You could see that here. There is no Cook's distance to be concerned about. And let's do a gamma summary since we've loaded it and see what it says. The gamma summary again shows similar results. The R squared adjusted, actually the deviance explained is 99.9%. So as it's depicted here, it's a very good fit. So if it's a very good fit, let's do some GG plots and see what happens. I'm going to do X and red, green, blue, and the value and see what happens. This will be exciting. Oh, it is a nice fit. The sun plays a role in it, but as you can see in the red, 1,000, just after 1,000 minutes, we have, that's where the sun was. So is this representative of what we observed? Yes, it is. Is it, and does it accurately represent the sun position? Well, really, if we view the sky again and we look at the actual times, we would expect it to be maxed out at 990, 1230, and it's maxed out at around 1250 because we're not pointing directly south at the time of this observation. So what are the takeaways here? Well, it worked. The sun got in the way. And again, when it comes to the vernal equinox, I will not be pointing the camera south. I'll point it north. I believe that'll give a better representation of how the sky will behave. Now, what we can see here is we can see some variations. This here is noise related because it's dark. These here, the variations are probably due to clouds and other objects like airplanes. So what we can then determine at some point through a machine learning algorithm or an artificial intelligence type solution is taking this information here, plotting it like this, looking for variations and determining, well, hey, something crossed our path, and we could learn from what crosses the path and how it behaves in the grand scheme of things here, and we could look for anomalies. I hope you enjoyed this video, and I just want to encourage you to push technology and see what you can get out of it. Thank you for watching, and have a great day.